Hello everyone. Welcome to our channel ML for Analytics. Today we will be continuing with our topic model relationships in Power BI. So in previous tutorials we had covered purpose of relationship. We had talked about disconnected tables. We had talked about relationship properties. We had delved deeper into cardinality, cross-filter direction, make this relationship active, assume referential integrity. So in this tutorial, we will be continuing that and we will be actually going towards the next step. We will be actually talking about evaluating the relationships. So over here, we will be talking about two types of model relationships. One is the strong relationships and the other is the weak relationship. So previously, we had seen that if we go to Manage Relationships tab in Power BI, we can actually go and change the cardinality. We can change the cross filter direction. We can actually make any relationship as active or inactive at any point of time. We can check or uncheck, assume referential integrity if we are working on direct query storage mode. But these two things, strong relationships or weak relationships, they can't be configured. They are actually detected by Power BI engine, and it actually depends upon our model, the model that we are making, the data sources that we are using, the cardinality that we are having between different tables. This is what is going to make any relationship as strong or weak. So we will be talking about that over here. So before that, let me talk about the two storage mode that are available in Power BI. One is the import mode and the other one is the direct query mode. So if I talk about import mode, what happens in import mode is that all of the data corresponding to the tables that we want to work on, they are actually imported into the Vertipack engine, Vertipack cache, I'd say, and that data is available in Power BI itself, in Vertipack cache itself. So that actually makes things faster for us because the data that is fetched, it's usually in compressed form. Power BI actually compresses it and then actually it stores it. So that is faster. If I talk about direct query mode, then I'm using native queries, and those native queries, they are going to hit the database, the source database every time. So what happens in this case is that both of these two modes, two storage modes, they actually constitute data islands. So by that I mean that if I talk about Vertipack or import mode, it is going to make different data island, and direct query data mode is going to make a different data island for me. So what happens in this case is that if you had imported two tables in import mode, then they are going to form a part of Vertipack data island. And if you had gotten those two tables using direct query mode, then they are going to make a direct query data island. So one is actually intra-island and the other one is actually cross-island. So if I talk about intra-island, these tables, they actually reside within the same data model. And if I talk about cross-island, both of them, they are going to reside in different data islands. So in case of intra-island, one and both of the two tables, they are going to lie in either Vertipack cache or in direct query. But if I talk about cross island, one of the table is actually going to work in uh, Vertipack or in actually import mode, and the other one is going to work in direct query mode. So this is an example of composite models. So as you can see over here, um, one of them is actually a Vertipack data island. The other one is actually DirectQuery data island. So what we are doing in this case is that in Vertipack data island, I can see that three tables are there. One is table A, other one is table B, third one is actually table C. Uh, and if I talk about DirectQuery data island, then two tables are there. So in Vertipack data island, table A and table B, they are related to each other by means of many-to-many relationship. Table A and table C are related to each other by means of one-to-many relationship, with table A being on one side and table C being on many sides. In case of direct query, I can see that table A and table B, both of them, they are lying in same data island and they are related to each other by means of many to one, I'd say. And in case of table A and table C, uh, with table A of direct query data island and table C of Vertipack data island, they are related in one to many cardinality. So you can see that all of these arrows, they are actually in two colors. One is black and other one is red. So black arrows, they are depicting strong relationships over here, and red arrows, they are depicting weak relationship over here. So as you can see over here, that in case of intra-island relationships, all many-to-many relationships, they are actually weak relationships. In case of cross-island relationships, they are always going to be weak relationships. Even if it's one-to-one or one-to-many, it's going to be weak relationship. If I talk about intra-island, one-to-one, one-to-many, many-to-one, they will be strong relationships. Only many-to-many relationships of intra-island, they are going to be weak. So this is one thing. Let's move to the next slide. In this slide, we will talk about strong relationships. As I had told you, they are formed in intra-island. If one side exists in relationship between two tables of the same data island, it is going to be an intra-island relationship, or I'd say strong relationship. Any one-to-many or one-to-one relationship will be a strong relationship. So next, in case of strong relationship, whenever we are hitting refresh on Power BI and our data model is refreshing, and if I talk about import mode first, then in that case, what happens is that our data structure having index mappings between the two related tables, it's going to be created. So why these index mappings are created? Actually, these index mappings, they actually help in making those queries faster, as in the in decreasing the refresh time. All the data, they are data rows, they are fetched faster uh, by means of these index mapping. So this is actually a part of optimization that is done by engine. In case of direct query, these index mappings, they are added to native queries itself. And these native queries, they are then sent to source database. If assumed referential integrity is disabled, then table expansion, it actually takes place in case of direct query by means of these indexes. So if I talk about assumed referential integrity, it's actually only enabled in case of direct query mode. And if we enable it, then the tables that are related to each other, they are fetched by means of inner join. But since it's disabled in this case, then what will happen is that this will actually be fetched table expansion is going to happen uh, in the intermediate state, and left outer join is going to happen between the two tables. So in this, on the left side, the many side of the table, which is on the many side of the relationship, is going to lie. On the right side, the table which is actually on the one side of the relationship, that is going to lie. So even if you say get any product in the sales transaction table, which was not present in dimension product table, even that product and that transaction will be listed, but the product rows in the join table, it will have blank rows. So even that is fetched. So these blank rows, they are actually called as unknown members. So any rows which have these mismatched key values, they are called as unknown members, and they actually tell us that our data, our source database, it needs cleansing. So in that case, what I'll do is that I'll go to dimension product table and I'll actually add that row over there. For one-to-one relationship, this expansion is going to happen by full outer join. If I talk about weak relationship, they are mainly formed in case of cross-island models, and one-to-one or one-to-many relationship in cross-island models, they are going to be weak relationships, and many-to-many relationships in intra-island models, they are going to be weak relationships. In case of weak relationship, table expansion will not occur. In case of weak relationships, inner joins are used. So we are not going to actually use left outer join or full outer join over here. Only inner join is used. So any kind of blank rows or any kind of mismatched key values and the rows corresponding to them, they are not going to be fetched in this case. Also in this case, the related function of DAX, it cannot be used to bring one side column values. So this related function, it is actually used to actually in case of row context only, so that it actually helps in flowing the row context from one table to other. We will talk about that in the future for sure. And also in this case, data structures having index mappings, they are never created. So guys, with this, I conclude this tutorial. So it was in this tutorial we covered modeling relationships in Power BI. We actually talked about purpose of relationship, relationship properties. We talked about strong and weak relationships. We talked about index mappings and how they are created in case of Power BI. We talked about import and direct query mode in Power BI. So stay tuned. And if you like this video, then please hit the like button. Share this video, subscribe to our channel, comment if you want us to uh, know your feedback, then please do comment. So stay tuned. Thank you.